think we can go. Good morning, everybody, and welcome to this session, which is called Benchmarking in the Cloud. I always try to adapt this session to the place where I'm presenting. So a few months ago, I was presenting this session in Germany, and the image for that was this, appropriate for Germany, and I thought this was appropriate for Scotland, but you fooled me. Scotland, I'm not really impressed. It's not raining, it's not cold, so I guess I'm in the wrong place. 5 minutes. Okay, yeah, totally possible. 5 minutes or 10, and that will change. Okay, so a big thank you goes to our sponsors. So how much did you pay to be here today? Did anybody pay anything to be here today? Nobody, and that's because these guys paid. So go and see where their website and visit them, see what they have to offer, because they pay for this great day of training. And a few words about me. My name is Gianluca Sartori. I'm an independent SQL Server consultant. I've been doing this for a really long time. The first version I have worked with was version 7. Does anybody here remember version 7? Oh, the guy in the back. So lucky you. Currently, I'm working as a DBA at a famous Formula One team. And if you want to read my blog, you can find it at spaghettidba.com. And if you want to follow me on Twitter, my handle is @spaghettidba. So the agenda for today. First of all, we will see different benchmarking scenarios and why we do that. And then we will see what are the tools and the challenges if you want to work with benchmarks. And then we will move to the cloud and see how things get a bit complicated. And then we will see workload tools that hopefully makes things less complicated. Okay, so let's go. First of all, definitions. What's a benchmark? Basically, a benchmark is something that describes the performance of your system in a given scenario. So right now, you take a snapshot of the performance of your system, and that's a benchmark. Fine. So why is it helpful? Because it helps you when you need to evaluate different scenarios. So you take a picture of your system now, and you take a different picture in a different scenario, and then you can compare the two. This is useful when you need to evaluate some possible scenarios, like what would happen if I moved all my servers to different hardware, or if I virtualized a non-virtual machine. What would happen if I upgraded SQL Server to a newer version or a different edition? The only way to do that is to take a benchmark in the new scenario and compare it with the current scenario. It also helps you when you want to tune your system. So you do things like turning some knobs at the server level, changing configuration and things like that. Or you change something inside the database, like a stored procedure, or some code you optimized, or indexes, some configurations inside the database itself. So you can take a different benchmark and compare it to what you have. So what goes inside a benchmark? Well, as we said, you need some performance data inside, and that performance data will be data that describes the performance of the system as a whole. So you have performance counters that describe things like number of batches per second, or how the CPU goes, or things that like wait stats that describe the weights for the whole instance. And then you have something that is really important inside the benchmark, which is the same performance numbers, but related to the queries that are running against your system. So you will have the text of the queries, and then some performance numbers that describe what happened when those queries ran. And you have things like CPU, duration, and reads and writes, and so on, for the single query. So what you want to do is something like this. You have a production system, typically a production system, and you have something that captures the benchmark, so the workload itself, the queries, and the performance numbers related to those queries, and creates a benchmark that contains the workload itself and the performance data. And then, in order to obtain a second benchmark, you will have to replay the workload against a test environment, against the destination environment. And while the replay is running, you will have the same capture thing that produces a second benchmark, and it contains the performance data, and again, all the workload with its performance data attached. So now you can compare the two, and the things you want to catch at this stage are things like regressions, queries that were running fine in the initial setup and are not running fine in the final setup. So you can go and see what happened. Plans have changed or something else, and you want to catch those before you migrate to the new scenario. Other things you want to catch at this stage are unwanted scenarios, so things that stop working altogether. You move from SQL Server 2008 to SQL Server 2017, and so you try to do this to replay your workload against SQL 2017 or 19 to catch regressions or things that stop working, and you might find that some things are broken because they are not supported anymore. Other things you want to catch at this stage, it's still possible to compare the performance you have in the initial setup against a different environment where you have something that changed in your code. So you can, instead of comparing for spotting regressions, you compare for evaluate the performance when you have changed something in your server scope configuration or database objects. Okay, so has any of you ever tried to do this? Okay, so if you try this, you know it is hard. Not impossible, but hard. And why? Well, basically, to do that, you need to set up a capture, and you need to know what to capture for your source workload. And you need to choose the appropriate tool to do that. The same applies to replay. You need to change the right tool for the job, and you need to know how to set it up. And also, when you have your two benchmarks, you need a tool to compare the two. So the main thing you need to do at this stage is choosing the right tool for the job. And we have many possibilities here, and let's see what are the tools that we have in our hands. So first of all, we need to capture the workload itself. So we need something that attaches to SQL Server and records all the queries that we run against the source environment. First thing that comes to mind is Profiler. Everybody knows Profiler. It's been around since forever, but it's nice and easy, but it has a non-negligible impact on the server. So if you run Profiler against a very busy production environment, you are sure that it's slowing down your source machine. So don't do that. What can we do instead? We could use extended events. Extended events were designed specifically to be to have a very low performance overhead on the server being observed. So it seems to be the right tool for the job. If you are recording to extended events files, they get big very quickly, so be careful with that. And also keep in mind that extended events are not compatible with all versions of SQL Server. So if you are working with version of SQL Server prior to 2012, extended events do not have all the events that we need to record a workload. Extended events were introduced in 2008, but until 2012 they didn't have all the events required to capture workload correctly. So if you're working with an older version, you still have SQL Trace. It's a bit old school, it's deprecated, they haven't added any new events since forever, but it still works. Also keep in mind that SQL Trace works with many analysis and replay tools available for SQL Server, so it might be the right tool for the job. Also, we need to capture some performance data from Windows, things like performance counters. In this case, we have counters that describe the behavior of Windows itself, so basically resource consumption like CPU, disk, and network. These are the kinds of performance counters that we need. And also we have performance counters specific for SQL Server, things like number of batches per second, page life expectancy, and so on. How do we know which counters are good and which counters are not good? There's a tool called PAL, and basically it's a PowerShell script that parses counter files and is able to analyze the counters and produce some nice reports. And one of the things that I like about PAL is that it contains a list of counters that are meaningful for many Microsoft tools, including SQL Server. So if you download PAL and you go into the installation folder, you will find some XML files that describes which counters are meaningful for SQL Server. So you didn't need to keep that in mind, you just need to read the list from PAL. Analysis tools. So we have many possibilities here. RML Utilities is a collection of tools from Microsoft. It's command line tools that allow you to analyze workloads captured on trace files. So you have read trace, which is a tool that, as the name suggests, reads a trace and writes the performance information about the trace inside a database. And then you have a tool called Reporter that reads the data from these tables. There's SQL Nexus, which is another tool based on RML utilities. Another possibility is to use ClearTrace. ClearTrace is a clever tool that reads a trace file and writes some performance information inside a database, again similar as readtrace does. But the good thing that ClearTrace does is it normalizes the queries. So instead of using the literals you have inside the queries, strips away the literals and replaces them with placeholders. So the same queries with different literals in the query get treated and analyzed as the same query, so you can get the bigger picture. So it's a pretty clever tool. What else do we have? PAL, again, it is good for analyzes the performance counters. And then there's a new tool by Microsoft, and it's called a DEA, Database Experimentation Assistant. And it's a benchmarking tool based on distributed replay, but now I'm told it's based on RML utilities again, so they're still working on it, and produces some nice charts with R, so the cool stuff for the cool guys. But actually I never managed to make it work, so maybe it's too cool for me. Replay tools, what do we have here? Profiler, again. Profiler is pretty easy to use if you want to run a replay. You just need to make sure you capture the appropriate events and columns to run the replay. And it's easy for replaying some workloads and setting some breakpoints and stopping and pausing the replay. So it's more useful for troubleshooting and debugging your workload instead of running a whole replay of a big workload. So a good choice here would be to use RML utilities again. There's a tool called ostress, has two modes of replaying a workload. One is called stress mode, so it takes all the queries and runs them one after another, so no wait between the queries. And in replay mode, it tries to respect the waits recording in the source workloads. So if you have a website and you have clicks that happen in like 2-3 seconds from each other, it will use the same weights in the replay, so to simulate in a more accurate way what happened in the source workload. Also, there's distributed replay here. It was introduced with SQL Server 2012 and does pretty much the same things as ostress, but supports distributing the replay across multiple nodes. You can use multiple machines to replay a big workload and simulating the multi-threading, the concurrency more accurately. Okay, so this is good, but what happens if we move to the cloud? So all these tools that we described were designed to work on premises. Let's see what happens if we move to the cloud. But cloud means many things. It could be any of the things we have here. So if you have a private cloud or on-premises, you take care of all the things in the stack here. But if we move to infrastructure as a service, you don't have control over the virtualization, the server, the storage, but you still have control over the operating system and anything on top, so SQL Server and all the data and the application. If you move to platform as a service, you only have your data that you can control, so think of Azure SQL DB, you only have your database here and your application. And if you move to software as a service, you don't have control over anything here, so it's not tunable by definition, so we're not really interested in that. So let's see what happens in these different scenarios. So if you have an Azure VM, all the tools that we described so far are still good. They still work because it's a virtual machine. You have control over everything, so not really an issue. But if you move to platform as a service, you have two possibilities. You could have a managed instance, and then you have control over the whole instance and your assisted mean, but you cannot access the operating system directly. So this means that you have some limitations. Traces are not supported because traces need to be written to disk, and you don't have a disk on a managed instance, or at least you have it, but you cannot access that. You can use extended events to record some workload, and you can write that to a blob storage. There's a way to do that. It's pretty easy to do. The other possibility is to stream the events as soon as they occur. There's a streaming API, and that works with a managed instance. You cannot run a performance capture with perfmon because it needs to write to the disk again. So all the performance counters that you have on a managed instance are the ones available through T-SQL. You have DMVs, you can access those performance counters through DMVs. The other possibility is to have a SQL database, so even more restrictions here. Traces not supported again. You still have extended events, but you cannot stream those. The only possibility is to write the events to a blob storage, and no performance counters again. So what's the solution here, none of the tools we have seen so far work with those restrictions, so what do we do when things don't work? We code a new tool. And this is why I coded Workload Tools. It's a collection of open source tools that you can find on my GitHub. It's under spaghettidba/workload tools. And it takes care of all the aspects of benchmarking. It is able to run a capture. It runs the workload analysis, and is able to run a replay. And also, things you won't find in any of the other benchmarking tools, it works against an Azure SQL database with all the restrictions it has. And also, it is able to do real-time capture and replay. We'll see in a minute what that means. Okay, Workload Tools is based on two concepts, listeners and consumers. Basically, the listener describes how you record the workload, so it is able to attach to SQL trace, to extended events, or to a file where you recorded a workload previously. And consumers are the consumers that do the actions on the events captured by the listener. So you can save the events to a file, you can analyze the events, so they get the queries get normalized and the performance numbers get analyzed, and you can get a report over that. And also you can run a replay, and you have multiple targets for the replay, so a normal database or an Azure SQL database. In order to configure Workload Tools, you just need to enter some information in a JSON file, so super easy. If you ever work with RML utilities or other tools like that, you know that it's a pain to configure those. And in this case, you just need to enter some data in a JSON configuration file. And also, to visualize the data, there's a built-in tool which is called Workload Viewer. It's a GUI that draws some charts. And if you want to go fancy with your analysis, you can attach a Power BI dashboard to the data captured by Workload Tools. Okay, so enough talking. I can show you that. We have some demos, and we can go ahead and see what it does. So first of all, we will try to analyze a workload, things that we're looking for. We could analyze a workload to capture expensive queries, so we could rank them by CPU or by duration and see what are those that are most promising for tuning. So how do I do this? I need to set up a capture with SQL Trace or extended events, and I need to know which events to capture. And also I will need to analyze the data, so I will need to run some reports or run some queries on the data. So sounds complicated. I will show you that it's actually very simple. So now we have here a virtual machine running on Azure, and here I have two instances of SQL Server, a SQL Server 2019 and a 2016. And I will use this database. It's called DS3, and it contains the data for an application that we will use as the source workload. And this application is, it's called DVD Store. It's a benchmarking tool by Dell, and basically it simulates an online website to sell DVDs. So it shows that it's a bit old as a tool, because do you still own DVDs? You probably don't. So it would be Netflix or something like that if they coded it today. Okay, so first of all, we will need to set up something to analyze the workload. So we need the workload, and the workload itself is this. So it starts this synthetic workload, this DVD store. So we can go ahead and run it. Okay, so now I'm buying DVDs like a crazy. And now I need to analyze this workload. What I will run for this is SQL workload. Is it big enough? Okay. And SQL workload is one of the tools included in workload tools. And I just need to pass the path to a JSON file. So let's see what's in the JSON file. So as I said, we need a listener, and the listener describes how we capture the events. It's of the type extended events workload listener. So I'm using extended events. I could use a SQL trace workload listener. It would be exactly the same. And all I need to specify is where to listen. So the name of the server is 2016, and it uses a filter, so a database filter. It captures only the events on the database DSP. I'm not writing here the definition of the extended event session. It will create that automatically based on the parameters provided here. And now I just need a consumer. So this, if you're not familiar with JSON, this is an array. So I can have multiple consumers attached to a listener, and it will do the things that are described by the parameters I include here. So I created here an analysis consumer, and all it needs to know is where to write the information. And we'll write the information in a SQL 2019 instance with the database name SQL workload 01, and it needs the name of a schema for writing the data. And this parameter, upload interval seconds, describes the interval for aggregating the data. So the workload is normalized, query is normalized, and performance numbers aggregated in intervals of the size specified here. So we will have intervals of 1 minute. So let's see what happens. Still buying DVDs? Okay. So let's run this. What happens? So maybe I can zoom in. And here it's saying, okay, I'm reading the session definition from this file, and it uses that file to create the session, and it's listening for events. So let's see what happens. In 1 minute, we will have the first interval written to the database, and the database is the one that we have here. So SQL workload 01. So, sorry. So let's see what it's doing. Should write to the database now. Okay, so now it says, this is the number of events it captured, so 3,000 events, and this has been aggregated into 22 rows. So this means that it's been aggregated, the queries have been normalized, and actually we have 22 unique queries in these intervals, and the performance data has been aggregated for these 22 rows. So let's see what we have in the database. We have some tables here in the schema that we specified, so capture, and we have the events in here, workload details, so we can go here, and see the data inside. So we have CPU, minimum, maximum, average, and reads and writes and so on for this interval, for this query hash that points to one of the queries captured. So, I keep going back here. It's not what I need to do. So once it's finished, what I can do is stop this. Once the source workload has finished. So let's stop buying DVDs. We don't have time to watch them anyway. So I can show you the data here. So at the end of the capture, what you have is something that shows you how the CPU was for your workload. So this is the duration and the number of batches per second. And you can zoom in if you want and select a part of your workload and see how it looks. And other things you can do is you can go to this second tab where you have all the queries, and they're ranked by duration and average CPU, total CPU, reads and writes. And what you can do is click on one of these queries and see the text for the query. And if you double click one of the queries, so this one is the one that consumes the most CPU in total, I can go here, double click and see how it goes in time and see the text. This is a sample of the text of the query. So I can go and have some more details about this query. That was easy, right? We didn't have to configure anything. We just started a batch file and entered a couple of information in a JSON file. So that's doable. Okay, so demo number 2. Going back to what we have just seen, if you're doing that with query store, you can get pretty much the same information. So if you're working on an older version of SQL Server, you can obtain pretty much the same information that you get with query store without using query store. Okay, second demo. This time we will have to capture a workload for a replay. And to capture a workload, if we were not using workload tools, we will have to choose between a trace file or extended events, right? But in order to be compatible with both, workload tools writes to an open type of file. It uses actually a SQLite database as the storage for the events. So let's see how that goes. So demo number 2. So again, we are running SQL workload, which is the tool to capture, and we provide a JSON file. So let's see the JSON file. In this case, we still have a listener of the type extended events pointing to this instance, this database, and this is the filter. Consumer, this time we have 2 consumers. So the one that we had before, this is for the analysis. And then we have a second consumer that writes the information to a SQLite database. So all the queries that we record in the initial workload get written to this file. So we can use it to replay it against the second instance. We can take home this file and move it to a second instance and use it as the base for a replay. So it's pretty easy. And in this case, what is interesting is that you get multiple consumers at the same time. So let's run this as well. Let's buy some DVDs again. And let's run. I was in the wrong folder. It almost fooled me. Okay, let's capture again. And so this time it says writing event data to blah, 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 this path. So we can go and see that file. And this is a SQLite file. And as you can see, the size is growing. So this is the size now. And it says 1,000 events saved in the file. So if we go back here, the size has increased. So it's writing to this file. And if you download one of those SQLite browser or something like that, you can go inspect it and see that it's actually a super simple database with one table inside, and it contains all the events. So why is this interesting? Because now we have a file and we can use it as the source for a replay, which takes us to the next demo. So we replay a workload. Problems here. How do we run the replay? It is important to set up the environment to be meaningful. This means that it needs to run the replay on the same data that you had in your initial environment. So in order to do this, you can run a backup, take a backup before starting the capture, and then you can restore the backup in your test environment in order to be sure that you are working on the same data. Otherwise, the behavior of the workload would be different and the comparison would be fair, or at least would be meaningful. And also, on your test environment, make sure that you are not working on remote data. So things like linked servers and things like that need to be non-operational. Otherwise, you risk working on data that shouldn't be modified. So the test environment should be as isolated as possible. Otherwise, you can damage something. Okay, other things to keep in mind. It's not only about running the queries. You also need to account for the time that it takes to download the results. So if you run a simple query that is pretty easy for the server to run, but it returns millions of rows, the replay needs to download those rows in order to perform the same operation performed by the source workload. And also, if you are planning to do that on an environment, on a target environment that is not next to your source environment, let's say in Azure, you're starting from on-prem and you're moving to Azure, keep in mind that latency is an important part of the time it takes to run the queries against the target environment. So in this case, if you're running against Azure, you can spin up a VM in Azure and run the queries, run the replay from there, and it should take less. Okay, so let's try to run the replay, which takes us to demo number 3. Okay, so this time I will have to run 2 instances of SQL workload. Why? Because one takes care of running the replay itself, and one takes care of analyzing the replay on the target instance, right? So let's see what happens. Replay runs SQL workload with replay JSON. So let's see what we have there. We have a listener that points to a source file, so a SQLite database. And we have synchronization mode true. So that means that the weights are respected in the source workload, so it tries to mimic the same weights. And consumers, we have the replay consumer this time. And here we have to fill in the connection info for the target database. In this case, I'm using an Azure SQL database and username and password. Don't bother copying the password, I will change it. And what else we have here? An analysis consumer. So this describes the analysis of the source workload. So you can record it to a SQLite file, replay it, and analyze it while you replay. And then we have analyze JSON. This attaches to the Azure SQL database with an extended events workload listener. And in this case, we need to specify where to store the extended events file. And this goes to a blob storage. So you need to set this up front, and then you can use it here as a storage for your extended events. Consumers, analysis consumer, and this writes the analysis data, the workload analysis data to the target database. Okay, so let's go and see what it does. We're still buying DVDs here. We don't need that anymore because we already have recorded the source workload. So stop it. And okay, so replay. We have start all here. And we have 2 instances now, and 1 is broken. Okay, perfect. What's up? Oh, access denied. Oh, okay, so something is wrong with my blob storage. So probably it has expired. It's not the only thing that has expired, because the SQL 2019 that I have here was evaluation edition, and it expired tonight. So I reinstalled it today in the speaker's room. But okay, no problem. So you get the concept. So trust me, it works. But I can show you what you have when you have a replay working. And what you get at the end is a database that contains data for both the capture and the replay. So you have 2 separate sets of tables in 2 different schemas, capture and replay, and you can compare the 2 using the reporter application. So what you have is something like this. The 2 benchmark, the baseline and the target benchmark. So black is new and green is old, and you can compare the 2. You can see how the CPU goes, and you see that actually the baseline uses more CPU than the benchmark. So running in Azure SQL database uses less CPU, so something is different there. And actually, looking at the duration, it's higher on Azure SQL database. So probably this has to do with what? Latency. Bingo. And number of batches per second is the same. Okay, so looking at the queries, now you have the comparison of the 2. So you have the difference in the total duration as one of the columns you can rank on. So now you see that this is the query that has the highest difference in CPU between the two environments. Okay, so this is maybe one of those that you need to tune the most to get some results. So you can go here, double click and see how this goes in time. So it's pretty easy to spot those that have regressions here. And this is, again, broken down by application, database, and host and login. So you can use this as to break down your environment even more. Okay, so that was easy, right? Let's go to the next demo. So now what we can do is run a real-time replay. How does it work? You can observe your source workload, and while you're capturing the queries, you can replay them to a target environment. So why do you want to do this? Sometimes you have some workloads that are not really easy to observe. Imagine that you have a workload that is comprised of many different actions that different users perform in different times of the year or the month. So normal activity during the month, and at the end of the month there's billing activity, and it has two different kinds of benchmarks. So in order to observe the whole workload, you would need to record it for a whole month. So imagine doing that to a trace file or an extended events file. That would be terabytes of data. It wouldn't fit on a normal server. So in this case, it's easier to replay. You're not really interested in the individual events, the individual queries. You're interested in seeing the performance over time. So what you can do is capture the workload, analyze it, the source workload, and replay to a target environment and analyze, and then you have the comparison of the two on a whole month. Okay, so how do I do this? It's actually pretty easy. So what you can do is, again, we need two instances of SQL workload, one for the replay and one to analyze. So in the previous example, we took the events from a file, but nothing prevents us from taking the events directly from the server. And this is what we're doing. So the replay has an extended events workload listener and a replay consumer attached directly to it. So we can capture the events from SQL 2016 and replay it directly to Azure SQL database. And also analyze the data to an analysis database. And the second instance needs to attach to the target environment and capture the data to an analysis consumer. So it's pretty easy to do this. Probably it won't work because this has been misconfigured, but let's try anyway. And of course it doesn't work, but yeah, trust me, it works. So what I can show you is what happens if you run this. I will show you what happens. I was in the wrong place anyway. So I can show you what happens if you run this for like 7 hours. This is 7 hours of activity captured on an actual client of mine who wanted to migrate from SQL Server 2008 to SQL Server 2017. Many plans have changed in the process, so you can spot the regressions before migrating to the target environment, which is pretty cool, I think. So what you have here, this is 7 hours of activity, and you can compare the two. You see there are some spikes like here, where CPU goes to the roof in the target environment. What's this? We don't know. In order to do this, we need to go to the queries, and again, rank by a difference in duration or a difference in CPU, and see what happens this is the query. It's pretty complicated. So what we can do is start tuning for the target environment, starting from the queries that are marked as a regression in the target environment. And then you can see this over time, broken down by application and host and login and so on. Okay, so again, pretty easy. You just need to fill some connection information, basically. So it's pretty easy to do. Okay, so benchmarking is not hard anymore. What you need to do is just download workload tools and be good. And that's pretty much it. So, questions? One question.
Can this be replicated on the Postgres SQL?
I wish, no.
No.
Hey, but this is open source. You can go and code the replay facility for Postgres. Okay, things to keep in mind. This is open source software, so I code this in my spare time, which is not very common. It's once in a blue moon, so is this perfect? No, it has bugs. Keep in mind that it has some bugs. So if something isn't working, don't be shocked. Just shoot me an email and I'll try to fix it as I can. Other questions? Okay, so thank you very much.